Welcome to this massive open online course on operating systems. Today we are going to see about virtual file system and remote file system. As we all know that file system is the basic structure of the system which maintains how a user can interact with the system by giving input, and how this input file is managed by giving proper access permissions for all the users who are accessing the file or any data. So, here now we are going to see a different form of file system called virtual file system. So, why it is called virtual? Here we have an interface that hides the abstraction of how the actual file is implemented. So, we all know that the operating system has different file formats. File systems, you can have different forms of file systems. Each and every file systems can be totally abstracted for the end user. Thereby, if you are giving a command, this command will be interpreted by the virtual file system, and it will send the command to the actual file system which is supported by this operating system. So, the user is not necessary for the user to interact to know about what type of file system is actually existing in the system. So, we can have a multiple file systems that can coexist in the system, and the user may not be aware about the type of the file system exists. So, for that purpose we are having the virtual file system concept. Today we are going to see about what is the need of a virtual file system, and what is the architecture of VFS, and how this abstraction is actually working by hiding the inner implementation. And the next part is about the remote file system. So, the virtual file system is basically about the type of file system in the single system. Remote file system is about how the file system is deployed in a remote machine. So, we have to connect from your machine through a network, and the client which is located in one place may not be aware about the operating system, or aware about the type of file system is deployed in the remote machine. So, if many clients are accessing a server, the server file system may be different, whereas the client file system may be totally different. But if you want to communicate, we should have an intermediate file system which can again hide and provide data, hide the implementation abstraction and provides data to the user. So, we are going to see about remote file system after this. Then we compare the local and remote, local which has the VFS implementation, and how the remote file system is used for accessing the remote files, and the various NFS concepts and remote distributed file system concepts. We will discuss about all this for the today's lecture. So, generally before that, for the quick recap, we can say about how file system is actually deployed in an operating system. It is about how data is stored and retrieved in terms of file creation, file deletion, and how to give access permission to the files, and how to maintain all this access permissions is the main job of a file system. So, OS main job is handling all how file system can be managed. Second is directory, which contains so many subdirectories and files, how to manage all this. Then access control, which provides the security and reliability for the actual file system, and we have a few examples of that. So, as we discussed earlier, the problem with traditional file system is the OS must handle multiple file system formats, though we have different formats, provide different implementation for each file system. There is an portability issues between two systems if the file systems are not supported. So, we are going for a concept called a virtual file system, which hides these different types of file system format, thereby the user can interact with the system. So, multiple file systems can coexist in a system if you have this concept. For having that, we use virtual file system. So, it is a software abstraction layer in the OS kernel. So, it hides the implementation of how file systems are done, provides an uniform interface to different file systems. So, if we have many file systems, we can have the same uniform interface, thereby the user is freed from how to write a query or how to get access from a system. So, you can have a simpler call that can send respective queries to the file system and retrieve the data. Allows application to use file without knowing the underlying system type, which is very transparent, and we can extend and we can also port. So, these are the main advantage of having a virtual file system. So, if we have this, we can have multiple file systems that can be supported in the same system. So, as another perspective, we can say VFS, virtual file system, acts as an intermediary between the user applications and the actual file system implementations. So, it is sitting in between the user application, which is in need of the data, and actual implementation of the file systems which are underlying in the system. So, VFS also enables multiple file systems as we discussed. It supports local and network file system, and we can have simplified system calls to operate on this file system. So, it is just about, for example, if you want to open a file, we can use simply open call or close call, create, like that. So, these are all the basic calls which can use, which can be used, but end-to-end implementation is different for each type of file system which you have in the system. But as far the user is concerned, the basic simple system calls can be used for accessing different file system. So, VFS architecture at the higher level, if you look at, we have the user space and kernel space. Of course, we have storage devices. In the user space, we have applications and system calls which are generated by the user. So, you can invoke various system calls to access the file or create a file or modify the file. You can read, write, whatever based on the access permission level which the user is having. And in the kernel space, we have the VFS layer which do the job of abstraction of between the actual implementation of the file system and the user. And we have the specific file system drivers that is implemented for each file system that can enable the simple system calls invoked by the application to access individual file system. So, if you look at this architecture in the form of a diagram, you can see we have the user process which has multiple system calls that may invoke. This system calls will be given to the system call interface. This interface will receive the system call, interpret that based on that system calls interface, based on the type of system call invoked by the application, the corresponding routine will be generated and this will be given to the virtual file system. The virtual file system will take care of sending this query based on different file system format. So, inside this VFS, we have the full deeper implementation about how to access files, how to modify file, or what are the access permissions we have to make on file. Everything will be implemented. So, we have different operating system. In the diagram, you can see Minix file system, DOS file system, extend file system, extend 2 file system. So, we have different file systems of different way. They can be used in the same system, and the VFS will give the respective query to retrieve the file or to check the access permission for the user, everything. On all this, we have the common buffer cache. So, buffer cache is of course, buffering and caching are different. So, it is a temporary storage where it uses the locally accessible data required for the various file system. Of course, we have the device driver that can interact with the various other outside hardwares that can invoke various IO requests. So, this is the overall higher view of a virtual file system. So, what are the various VFS data structures? So, that is actually an abstract object that VFS uses for enabling this concept of virtual file system. So, we have objects like super block, which is the main object which contains the metadata about the overall file system. So, it is information about the mounted file system. So, only if the file system is mounted, the files can be accessed. Otherwise, an unmounted file system, we cannot access any file. Similarly, how we do mounting files in the previous presentation. So, here also we have the file system to be mounted, that is the super block which contains the overall metadata structure of the entire file system. The second is the inode for every file. It is a metadata of a file which contains the information about the ownership, access mode, file type, and data blocks with the file's content. So, this also contains metadata, but of minimal level. For each file it has that, but it will not have the file name. It has only the information about the file like ownership, access mode, file type, and data blocks with the file's content. The next is the entry, which acts as a glue between this directory entry mapping with the name and the inode number. So, once the inode will have its number. So, this entry will act as a glue that connects between the file name and the inode, thereby the files can be accessed by many directories or many file systems. Single file can be accessed. Next is the file object, which is the actual file which is responsible for creation and opening a file. So, it is the object which creates the file, and the rest of the things are maintaining the files and how the files can be efficiently handled in the system, thereby multiple copies of the same file may need not be maintained. Only thing is we have to refer using symbolic links. So, these are the various abstract objects that we use in virtual file system. So, if you want to see that in the form of the actual connectivity or link between all these objects, so you can say file object, of course, we have the file object, and all these file object will have connected with at last with the super block object, which contains the information about the whole system. So, you have the Dentry object, which acts as a glue between the file name and so Dentry object is the fundamental thing which contains the file name and the inode number. Inode object contains information about all this. So, this is the way which everything is connected. So, we have many files can be connected with the Dentry object, and Dentry object in turn connected with the inode, or it can connect with the super block object. So, all the metadata will be available in the last two, and the Dentry object is the connectivity which is responsible for connecting files and the inode, and of course, we have the file object. So, at last everything will be mounted. So, using VFS mount. So, only if it is mounted, the files all files should be mounted, thereby the file can be available for accessing. So, if you look at the flow, how it operates, the VFS system. For example, if you want to open a file .text, you have to call the call called open call, and VFS the system call interface will receive this open call from the user application, and it will generate the system calls output according to the file system. So, we have it sends to the VFS, it receives the system call. VFS will resolve the path using the Dentries. So, Dentries will have the connectivity between the file name and the inode number. So, which file we have to create, where we have to create, this path will taken care by the Dentries. Then once it is done, the corresponding file system driver, which is unique for each file system, is invoked, and the corresponding file object will be returned to the application. So, this is the generic flow of a virtual file system to access any file. Major advantage of this one is the file system independence. So, there is no need to depend on any particular semantics to perform the operation of creation, open, delete, or whatever. So, it is totally independent. It is very easy to add new file systems. Only thing is you have to mount if the file system is created as new, and API is uniform for all. So, you just call this uniform basic calls, and this will generate the respective file system specific commands from the VFS. And also it supports network and special file systems, where remote file systems can be connected in a network path, where the file system can be stored in a server or in a distributed systems. From there we can access by all the clients, and it improves system modularity. Yes, we have different systems can have different file system, but still any system can access any file system. But if you look at the use case of a virtual file system, you can see in this diagram that we have different structures, like we have a cloud storage, we have an embedded device totally different, we have a supercomputer, we have servers. So, servers we have centralized file access. So, it can have multiple servers have multiple file systems, and we can use VFS for communication. So, you can communicate with any of the devices, where almost everything will have storage and follows different file system. So, here the VFS is acting as a bridge between all these different diverse storage systems into one unified interface. So, it is just access the data, that is it. So, if you click retrieve or download, it is the only one action which you are performing, but the download happens from different storage, one maybe from the cloud or maybe from the embedded device attached, which actually a lightweight file handling system. According to that system, VFS will generate the query, and we have a supercomputer which is having high performance capability. For that also it generates the query, and also for the servers where multiple clients will access simultaneously, in that also we have a common access. It can be accessed by anything. So, servers are here, supercomputers can access the server, embedded device also can access the server, cloud storage also can access the server. We can also access from the cloud data. So, whatever. So, ultimate objective of this diagram is the server is having multiple file system, and all the systems can be accessed by any type of devices with the help of the intermediary virtual file system. The next is remote file system, where we have file systems in a remote server, like the example which we discussed, that gives a path to discuss about this. It is about the remote file system. We are accessing files stored in another machine which is connected via the internet, so via network, whatever. but the client which is going to access this file doesn't know that the file is available in the remote system. It appears as if it is available in the local machine itself. That is the feel the remote file system will give. Uses network communication. Of course, if you use network communication, there is some delay between the server which is going to feed the data to the client based on the bandwidth or what many factors in the network. Apart from that, the access is as simple as accessing from a local system. So, the basic example of a remote file system is NFS, network file system, and SMB is one thing which called a server message block, and the CAFS, common internet file system. These are all different remote file system interfaces that can use to access file from a remote server. So, the objective of having remote file systems is earlier we depend mainly on these individual machines before the internet got boomed, but now we access all the files not only from our machine, which it is accessed from different machines across the network and also from the cloud. So, we have a system which supports that. So, the first thing is we have to share the resources. For that, use RFS, that is remote file system, then manage the data centrally. So, when you have different sources of data, all this data can be stored or managed at the central place. So, for that we need connectivity. So, you can use this RFS remote file system for that. It reduces data duplication. So, there is no need to maintain different type of data different places with same copy. You can avoid that using remote file system concepts. It supports distributed computing, and as I said before, it enables cloud and enterprise storage. So, these are the main thing which is moving forward towards remote file systems necessity. The components of remote file systems are the client system, the server system, the network, and remote file system protocol. We have different examples, NTFS like that, NTES, network file system, NFS, and other cases, SMB like that. So, client sends a file operation request to the server, and server performs the operation and it gives the result. This is the overall client server communication. So, basic components are this. So, this the client issues the file system calls, and of course, we have file system calls for performing operations on the files, but we have network system calls to establish the connection. That is a totally different concept. We are not talking about network connectivity here. We are just talking about how file system calls can be used to access data through the network. So, request converted into network messages. These requests are nothing but the system calls which are generated for operating on the system files, and even for this file requests we need to create network related messages by marshalling some parameters, and after receiving the server it demarshals that and it will process the query. So, the server performs operations on a local disk and results sent back to the client. So, operations basically of this open, read, write and close. As the file shows that the client is accessing and the server is sending a file back. So, the server is maintaining a queue where we have multiple files, and all these files will be used by all the clients. So, the request will be sent to the server and server will move the file to the client. So, the basic remote file system, one of the example is network file system NFS. It is developed by Sun Microsystems, and it is basically used in Unix based remote file system as a remote file system protocol. It uses RPC. RPC is the remote procedure call where the client will generate a function call as a request by using some passing some parameters, and the method available in the server, we call it a stub and skeleton. So, the server will execute that and it will give a result. The result will be sent back to the. So, it is a stateless protocol. It will not maintain any state. Once the client request is sent, the response is generated independently. So, it is a stateless server model file system. If you look at this diagram, we have the NFS client, it is mounted and it is sent to the request to the server. The NFS client, the server file system is also mounted as a shared file system, and these files can be shared by multiple clients. The features are transparent remote access and mounting remote directories. You can mount the remote directories for access. So, this enables accessing remote files using network. If you want to compare the VFS and remote file systems, so VFS treats remote file systems like local ones. So, we have different files, and all these files can be accessed by VFS interface as an intermediary, and it treats as a local file. So, how VFS file system can be used as a access remote files. So, here we use remote file system drivers plug into VFS layer, thereby it can be used to access the remote files. So, applications are unaware of file location. So, always if you generate a request using the application get the data, but it is always unaware where actually the file is located. So, this is how automatically this VFS RFS will do in their content retrieval, even though the content is in local machine or remote machine, but the application does not know about that. Same system calls for local and remote files. Yes, as I said, it's since it has an abstraction, it generates the same question, but for taking data from the local file or from file system or from the remote file system, but the same system calls is used. So, just open here refers to open in the local machine or open the remote machine. It is actually taken care by this remote file system. So, if you look at the challenges in remote file system, as I already mentioned that there are a lot of issues in the network path where we have network latency, we have a lot of latencies involved because of the distance and the intermediate devices. Partial failures, yes, we are not aware about where the failure will actually happen, because the control is not within the individual system. It is many systems are involved in the entire path, and the consistency issue is there because of remote access. Security is a major concern. Of course, we have various protocols which has control over the security, but still since we are accessing from a remote place, that is why we have all these issues with the internet. We have all the anti-virus softwares used for protecting our data, and the performance overhead is mainly affected if you access from a remote system. So, these are the main challenges. For that we have a lot of research and optimization techniques we adopt to enhance all these failures. So, in spite of all these issues, we can have the mechanisms that can improve the performance of the system by doing some optimization like client side caching. So, no need to fetch the same data from the remote system quite often, which is not changing. So, we can download, we can retrieve once and we can put that in the client cache, and still it can be used for some purpose. And if you perform some write, it is not as speed as what we actually do on the computer. So, we need buffers for writing. So, the speed at which you send data will not be written as the same pace. So, while storing in writing takes a lot of time. So, we have to store that in the buffer. Read ahead techniques. So, these are all some techniques which you can use for predicting what type of instruction or content which you may retrieve in the near future. That prediction, if you enable that, will give a better performance. Read ahead techniques we can use, likely to be accessed in the next request. Cache consistency protocol. So, we have to maintain the consistency of data in the caches. So, for that we have a lot of protocols that are available, like MESI protocol, which produces. So, the trade off is performance versus consistency. So, here if you increase the performance, and also consistency has to be maintained. So, performance and consistency is the main thing which you have to consider in remote file system access. So, if you want to have a higher performance, you have to provide the correct data, and the network latency also should be handled. The issues and the performance metrics which you can concentrate for improving the overall system output. If you want to compare exactly the VFS and RFS in terms of various aspects like type, location, purpose and transparency. If you want to say type, it is an abstraction layer which hides the file system and the user application, whereas RFS, remote file system, is the network based file system which also acts as an abstraction between the actual device which is located at the network and the client. Location is the kernel. Virtual file system operates in the kernel, whereas the remote file system is operating on the client server basis in the network. The purpose is to provide the uniform interface for all the user requests and the different file systems implemented, and RFS purpose is to access the remote files. And the transparency is there is no discrepancy about different types of file systems. So, file system type is common and it is hidden by the VFS, and in terms of RFS we can say the file location is hidden. So, the application does not bother about where the file is accessed. It just if you click, it will be sent to your application which is making the request. So, as overall we discussed about a VFS which provides the common interface to the diverse file systems which exist in the same machine, and it simplifies OS design and enhances portability. So, we do not need to have multiple operating systems, extension of an operating system to handle this different file system. So, it enhances the portability issues, and remote file systems enable network based file sharing. So, this RFS is enabling us to access files across the network which is located at different servers. So, VFS seamlessly integrate both local and remote file systems. The application does not know about the file type or file location irrespective of whether it is local or it is in remote, and it is mainly helpful in the modern operating systems where we purely depend on the external devices for accessing the data. Thank you. So, we have concluded the virtual file system and the remote file system, and we will see with the kernel IO subsystem in the further coming slides. Thank you. Thanks for listening.